Good day, and welcome to our webcast, Industrial Ethernet Networks and Edge Computing, brought to you by CFE Media and Technology and sponsored by Epicor and GE Digital. We're joined today by Thomas J. Burke, Global Strategic Advisor, CC Link Partner Association. I'm Kevin Parker, an editor with CFE Media. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. Edge computing environments can decipher and analyze terabytes of data from disparate devices and networks and turn it into useful information. The challenge is the lack of standardization. How can data be normalized from a syntactic and semantic perspective into helpful information? During this webcast, the presenter will discuss the importance of the technical innovations at our doorstep, including time-sensitive networking, 5G, Wi-Fi 6, IoT, and edge cloud computing. He will explore interoperability's value proposition in a multi-vendor, multi-platform environment, requiring secure, reliable information integration between information and operations technologies. Stay tuned to learn how industrial Ethernet technologies historically approach standardization and how rapid convergence onto a single physical wire leverages TSN technology for real-time communications and concurrent configuration applications. The key to data communications in the OT world is determinism for control applications and the configuration and programming of devices and applications that do not themselves require deterministic communications. You see before you the learning objectives for today's session. This event is a live educational webcast presented on June 8th, 2022. The educational category is technical health and safety. Here are some tips to help you get the most from today's webcast. If you experience issues with the slides or audio, refresh your browser or click the refresh media button under the presenter's picture. Control the volume of this webcast by adjusting the volume on the computer or on the platform. For technical problems with the audio or slides, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. The Ask a Question box is also used to ask the speakers questions. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You'll receive an email within a week with the link to the on-demand event. To take the Learning Unit exam, use the Learning Unit exam tab option at the top of the screen. The exam will open in a separate browser window. You can complete the exam after the webcast. However, the link will break when the webcast signs off. We'd now like to share with you a brief video from today's webcast sponsors, Epicor and GE Digital.
What the world needs now is people. People who see things just a little bit differently, who go out of their way to find a new perspective and a new way forward. Because seeing a smarter, healthier, cleaner world isn't something that's far in the future. It's something we're building now. GE, building a world that works.
Welcome back. I'd now like to introduce today's speaker. Thomas J. Burke is Global Strategic Advisor for the CC Link Partner Association, found at www.cclink.org. Mr. Burke's background includes being the former OPC Foundation President and Executive Director. He drove the vision of OPC and has pioneered OPC UA as the foundation and solution for multi-vendor, multi-platform, secure, reliable information integration, interoperability from the embedded world to the enterprise. Mr. Burke has spent the majority of his career developing hardware, software, and firmware for industrial automation, spending a great part of his career at Rockwell Automation. Tom has a bachelor's degree in theoretical mathematics from John Carroll University in Cleveland, Ohio, and a master's degree in computer engineering from the University of Dayton in Dayton. Thomas, welcome to today's webcast, and please go ahead.
Thank you, Kevin. Thank you for the wonderful introduction. And it's really, I'm very excited to be here, and it's a real opportunity to really talk about the industrial Ethernet and talk about the world we are in today. I've always talked about the importance of industry standards, and the way I talk about industry standards is success is measured by the level of adoption of the standards. And I'm really pleased to talk about the work that we've been doing overall with all the end users and collaborating with all the suppliers and the organizations, really focused at, the whole concept of, multi-vendor, information integration between IT and OT. This is just kind of a brief introduction of me. There's some pictures up here, and you'll probably get asked a question. I've got some bad habits. The bad habits are I collect cars. This little left-hand corner is called a Bricklin, and it was invented in 1974 through 76, and not a lot of them, but I've owned a couple of them. So, and I've also been doing some things for some other customers, and yes, I do ride a Kubota tractor, and we'll go from there. If we talk about, really the key technology trends, I like to work with the guys at the ARC Advisor Group, and one of the analysts that I've got to know over the years is Craig Resnick, and I was asking him recently, what do you think, Greg, are the key technology trends from your view in 2021 and 2022? And if you think about what 2021 was and 2022, it mirrors it exactly. It was all about the digital transformation. We talked about the ability of this thing called the open process automation, and that was an initiative with the oil and gas community where the end users were really working together to standardize on data information models. In 2021, we talked about IT-OT convergence. We talked about having integration with the enterprise, again, as basically the fostering technology for moving data and information. In 2022, though, we recognized the whole concept of the supply chain. And what happened there was, the inability for us to get the necessary components and the parts to actually ship products, right? We've seen this in the, the automotive industry. You can't order a car easily because of the inability of, getting the necessary chips. So we've started to really think about this whole concept of the real-time smart supply chain. And then, talking about basically the machines and, what do you do with HMIs and, how do you leverage AR and VR as critical components are really the key technology trends that we're starting to look at in 2022. Think about the digital transformation as essentially it's the integration of all this technology across the board from both a business and a technical foundation. It's all about, your digital transformation journey and how do I deliver value to our customers and make sure that the suppliers are working together to develop, multi-vendor interoperable products, right? You want to continually challenge the status quo. We've got to look outside the box, and you want to take a look at the opportunities to really increase, the business value proposition of your respective factories or process installation. I think about the 6 stages of the digital transformation, And, you know, if you think about where these were when we first started, it was just business as usual. And then we started thinking about how do we formalize it more. Then we started thinking about strategic. And then we started thinking about how do we converge all these different, you know, disparate devices and disparate networks into a common framework. And now, really, if you think about we're now talking about the importance of adapting and the importance of innovation and leveraging innovations in a, you know, strong way to really assess and be able to build your factory and smart factory of the future. You know, from an end user perspective, they were stranded with what I call islands of automation that were very disconnected, right? I talk about the disconnected, you know, applications and the devices and the networks. And, you know, the problem was that, you know, end users were faced with, they'd buy products from different vendors and the stuff wouldn't work together. They just expect from a consumer perspective that all this stuff should work. And, you know, I've got a huge installed base basically of devices and applications out there. How do I take all those legacy devices and bring them forward, you know, without doing a revolution and throwing everything away? You know, the whole concept of that I was developed over the years about with OPC, honestly, Kevin, was all about, you know, the importance of standardization and the importance of having multi-vendor interoperability. And, you know, essentially, you didn't want to be tied to a single vendor anymore. The end users expect that I should be able to buy a product from one vendor today and be able to switch it tomorrow with a different vendor for different reasons. You take a look at the manufacturing timeline. You know, Industry 4.0 has been talked about quite a bit, you know, and everybody knows what Industry 4.0 is. But, you know, we started with, you know, from an industrial revolution perspective, you know, it started with mechanical. You know, then it went further, you know, down to assembly lines. And, you know, the third revolution was really about the programmable logic controller, you know, that we started with the Modicon. And now the fourth revolution was really about, you know, standardization and really moving things forward. Well, you know, now Industry 5.0 is coming out and around, and everyone's thinking about common information models, you know, having standardized models. So I've got two different, you know, robots from two different manufacturers. They got to look the same. They may operate differently, but they've got to look the same. And the importance of cybersecurity is now a very important part of the Industry 5.0. A lot of the design principles in Industry 4.0 and all the regional equivalents is all about, you know, the interoperability, interconnection, this whole concept of having transparent information, you know, basically being able to share data and make the data available, you know, from all these different devices in the OT world and transforming that into information basically into the IT world. You know, these are the kind of design principles that really laid the foundation, you know, for Industry 4.0. The concept of being able to not have centralized decisions. Now I can do decentralized decisions because now I have connectivity to all my different devices, you know, across the globe. The industrial Ethernet really started to change the whole world. I mean, when we first started out, it was foundation field bus, you know, it was 4 to 20 milliamp. And then we advanced into the industrial Ethernet. And the industrial Ethernet includes a lot of different protocols out there that all have a level of determinism and real-time control. You know, everyone's familiar with, if you're not, the different protocols like EtherCAT or Ethernet IP or Profinet, Circos, CC-Link Internet, Industrial Ethernet, and Modbus TCP, are all the different, you know, networks that are out there, just to name a few. But the challenge that our customers face is how do they take all those different networks and all those different devices and have them work together? And that's part of the whole challenge of when you start thinking about smart manufacturing and what we're trying to do. So if you take a look at the shop floor and all the different devices that you have on the shop floor, I want to be able to get data from all those different devices. Then what I want to do is I want to get that data, and I don't want to push the data into the IT world. I want to push information into the IT world. So you do that via these edge computing type products that basically analyze the data and turn it into useful information that's then available to the IT system. So when I think about smart manufacturing, I think of the reality of the convergence of IT and OT and tying all those different networks that I just mentioned before into a standardized platform that really allows, the interaction of all the computers. So Mitsubishi, who I work for now, has been focused on developing what's known as the e-factory, and it's all about smart manufacturing and leveraging the architecture where you partner with a lot of different companies to really deliver smart manufacturing. If you think about how IT and OT is defined, again, it's all these different devices, it's sensors, it's PLCs, they're all connected on the factory floor through all these different OT networks, and then the information technology is all connected via TCP/IP. And what I want to do is I basically want to be able to take that data from all those OT networks and make it available through information into the information technology or into the IT world. And that's the key to really having integration and helping our customers with their digital transformation journey. You think about, I've got all these different protocols I got to deal with. I got to convert the protocols. I got routing. I got switching. And then what are a lot of the apps that are at the IT space that basically are out there? So we talk about the edge. We talk about fog computing. We talk about cloud computing. And it's really about leveraging and having all this whole network infrastructure necessary to really connect all this world up. There's a lot of different components in the digital transformation that you need to take advantage of. When you think about IoT, it's nothing but all the things. It's your phone, it's your coffee maker, it's your sensor, it's your robot. All these are just things, and all these things basically have a data model inside of them. And they all need to have communication, and they all need to have the ability to grab the data from all those things and push that data, through a network infrastructure to ultimately convert that data into useful information and push it into cloud-based application. That's a critical thing if you want to do a digital transformation. I want to make everything digital. It's basically can be on-premise or off-premise, and basically it allows you the capability of connecting up all these things, gathering data from them and turning it into useful information is really the key to really making your smart factory a reality. I talk about the different things that are part of an IoT solution. You've got your cloud, you've got the IoT platform, you got an IoT solution, and then you have a myriad of IoT applications that really have, the framework for converting that data. So if you look at this thing, I've got universal connectivity across the board with, and I'm proud of OPC and BACnet and Modbus and all these different networks that are out there that provide the connectivity standards necessary for streamlining data from all the different devices into that IoT edge platform. But then what I want to do is I want to take the data and on the edge and basically push that up into the cloud. And then ultimately the cloud, basically you have the client applications that connect to the cloud. This is IoT convergence at its best. And this is the important part of this. You take a look at a lot of the different networks that are out there. Everyone wants to connect everything. One of the goals of a lot of these industrial Ethernet organizations, including the CLPA, which is CC-Link Partner Association, really is standardization. OPC and its information models are very important. OPC has been collaborating with a lot of different standard organizations, developing OPC Way companion specifications for standardization. So now I got the network, I can connect everything up, but I can also understand the syntax and semantics of the data. Ethernet and TSN have been a reality since 2018, and TSN is truly what I call a game-changing technology, because the beauty of TSN, and it's one of the innovations that are very crucial for the digital transformation, is it allows all these different protocols to run on the same physical wire. And it allows, Kevin, the ability to have, I can do control and I can do configuration of devices on the same physical wire. So basically, I can add a new device on the same physical wire without affecting my control application, and that's the foundation of the TSN technology. And we're working with a lot of different organizations. It's an IEC standard. Avnu is one of the organizations out there that stands for audiovisual. TSN actually was a technology that was, started in the audiovisual industry, and then it's moved on to basically inside of the automobile. A lot of your automobiles, you got like 3,000 plus sensors in there, and TSN has become the technology for connecting up all those sensors for a reason, because it's all about guaranteeing and not missing a single data point. Because if you've got a sensor, you can't afford in an automobile to miss a data point. In the industrial automation world, if you want to think about safety, you want to think about an automotive assembly line, the TSN technology becomes a very important part of that strategy. You can't afford to miss data. So basically with the TSN technology and working with all the industrial Ethernet organizations, we've got the ability to have safe, reliable application. The OT and IT integration with the TSN technology, again, it allows safety, motion, and control to run on the same physical wire. So I can mix all these different, industrial Ethernet networks on that same physical wire, and I can do TCP/IP at the same time. So this coexistence of multiple protocols on a network is the foundation of the TSN technology, which is what we're talking about today. It's an innovative, standard, and it's continuing to evolve, and many of the industrial Ethernets are already developing and have released technology based on TSN. I like to talk about TSN because it's really the technology that meets both IT and OT. I've got the ability to take, all these disparate networks that previously before did not work together. They worked great on their own, but now with the TSN technology, I can take this stuff, they're all running on the same physical wire, and really it improves the efficiency of basically exchanging data and information between IT and OT very easily. The idea of having a single physical wire, and I talk about single pair Ethernet, I talk about power over the data line, these are key things that the TSN with the TSN technology will now be able to take advantage of. So I've been talking a lot about TSN for a reason, because it's one of these innovative technologies that I recognize was important for the audiovisual. It's important inside the automobile. Well, guess what? It's also important in the industrial automation space. I've got critical data that I need to get, and I need to be able to get this from all these different devices and different networks, and now I can do it in a seamless fashion, leveraging TSN. The other thing that we've been doing is recently, and it was announced at Hanover last week, was that TSN, an organization called TIACC, which stands for the Industrial Automation Conformance Collaboration. It's a partnership between Avnu, which is the audiovisual organization, CC Link, ODVA, OPC Foundation, and Profinet. And basically they joined together to develop a single common conformance test plan for the IEC 60802 specification, which is the profile of TSN for industrial automation. The fact that all the organizations are working together, and basically all these organizations are now pushing out their protocols on top of TSN is critical and provides the way of interoperability for the future. That is the most exciting thing that I can think you can take a look at. From a system approach, you take a look at all these different industrial networks and leveraging them all together. I can now take all these different devices independent of the network they are on and essentially be able to get data from them. So whether they are wired or wireless, it all fits into the architecture. I got terabytes of data I can get my hands on now, and that's exciting for the manufacturer. That's what the customers really want. They want the ability to have, configure and get the data from all these devices, and then be able to take that data and analyze the data and put it into their historians and put it into their enterprise aware application. There's a lot of wireless sensing network technologies that are all part of this thing. The stuff with LoRaWAN 1 and the cellular cat and things like that are very important. We're working with the smart mesh IP guys and Wi-Fi overall. So, you know, people are talking about 5G, they're talking about Wi-Fi 6, talking about 6G. These are all important things that are necessary because a lot of devices in the factory, with now what we can do, they can be wireless. And the beauty of having wireless and just having batteries in these devices, right, is very important because now I can hook up devices in ways I never could before. But most importantly, I'm getting data out of these devices. So whether you're doing wired or wireless, right, all these different network technologies are really coming together to really help you with your IT, you know, OT convergence strategy. I talk a lot about the different performance capability. This just happens to be the CC link technology and the fact of, you know, how you can push data at a very high speed. But the most important part is the topology and the direction that we've went in allows you to have virtually unlimited capability. And that's the big thing. So, you know, you can think about having 65,000 different points out there, and that's a very big, you know, thing. So I got 65,000 different devices out there that potentially can be connected, and allows you to merge all these different topologies together. So it's a time-sharing network. That's what TSN's all about, and it's a high-speed performance. Most importantly, you don't miss data. A lot of the companies are engaged in TSN. This is just a small sample. They're all recognizing, you know, the importance of this. It's all the big guys, it's all the small guys, and basically they're all adding TSN to their technology. So whether they're in the OT world or they're in the IT world, which is, you know, some of the companies that are engaged, they're all recognizing that time-sensitive networking is very important. Customers are demanding it. They're demanding this technology as the mechanism for, you know, connecting up all of their, you know, disparate devices and networks because they don't want to lose data. They want to gather all their data and make it information. This is just some more of the companies that are out there that are developing, and I apologize to the companies I've missed. From an industry perspective, with what everything is going on with digital transformation, I don't care if it's automotive, I don't care if it's a semiconductor, you know, there's a lot of big innovations with batteries right now, particularly with all the electronic vehicles. You know, I'm working closely with the packaging and the food and beverage industry. You know, essentially, it's all about all these different industries, including building automation, that are all talking about the most important thing they have is we have data. How do we get the data out of all our devices in a standard way? What's also being part of this whole thing is this whole concept of information modeling. Information modeling is a critical component in basically standardization, and all of the companies are recognizing, you know, we want to have the same information model. One example is packaging. Packaging is serviced by an organization known as OMAC. OMAC is all about a set of suppliers and a set of end users that are really focused at an information model for packaging. This information model happens to be known as PACML, and it's one of the standards that all the suppliers and basically the system integrators are using. So you can have multiple packaging machines being able to talk together seamlessly, and they can all speak the same syntax and semantic language. All of the other industries like robotics, vision, are all doing very similar things in their standardization for their data models in their respective devices. This is the critical thing in standardization. Again, I talked about the Internet of Things. You know, it's a network of a lot of different smart devices. And if you think about what we've been doing for years, you know, your phone, your computer, your car, a coffee machine, these are things. And basically, then there's all the control systems, which, you know, are all the embedded devices. It's sensors, it's software, it's actuators. I want to have connectivity between all these different devices. So if you think about, there's just literally billions of things out there that are ready to be connected to your control system in manufacturing, build these, and all of the infrastructure. So the business potential is if I can get data out of all these devices and I can get it into the edge and I can analyze the data and turn it into useful information, I've solved a big problem. There's a lot of reasons for adopting IoT. There's a lot of different industries. I talked to all the end users. The big reasons for IT adoption is they're thinking about safety. They're thinking about security. If you think about what I said about TSN being a game-changing technology, it really provides the ability to have safe applications and safe, smart manufacturing because I'm not going to lose data. It also provides a high level of security. So I can take all my operations, I can optimize them, I can do quality, I can do so much more things, basically increasing, employee productivity at an IoT level. So, there's a lot of complexity of, scaling all these different IoT devices. But what's happening is with all the great technology that's coming out, and particularly, the ability to connect up all my devices, whether wired or wireless, serves all these different industries. So, we're expanding into the healthcare industry. I'm doing a lot of work in the retail industry, power and utilities, oil and gas, and obviously manufacturers can now reap the benefits of this integration. Control systems versus IoT systems, control systems, basically you're scanning, endpoints for the data. Okay, very interesting, and it works well. Speed and determinism is very critical, and typically in most control systems they're wired. With IoT systems, though, essentially these endpoints now are automatically publishing the data. So instead of scanning or pulling the data in your typical control system, I'm pushing the data. I'm pushing the data into relays. I'm pushing the data, and allows the capability for having a lot of different networks all together, low speed, low bandwidth networks. I can do a lot of things wirelessly. These are the advantages of these things. But most importantly, we're going to be able to take all these different control systems and the legacy devices and the new IoT systems and make them work together. I talk a lot about the challenges, right? We talk about how do I establish bidirectional communication with all these different IoT devices. Security is the key. There's many secure transport protocols that I've been working with directly. I like to talk about AMQP and MQTT and REST and the different web services as mechanism. We talk about how you have to authenticate, at the device level for, my secure IoT solution. There's a lot of things that are going on where Microsoft is pushing their IoT hubs and essentially the different levels of TLS security and how it supports it with like X509. I want to automate my, IoT devices and registration really to accelerate deployment. I want to basically take my phone and instantly be able to connect it up and be able to get data. This whole basic concept, comes out with all the cloud providers and basically allowing the capability for having new devices easily added and to get to the data. From an IoT example perspective, what I've seen, there's a whole connected infrastructure, the things we talk about, with 5G cell towers. I think about, oil and gas industry. I think about building systems. Their needs are all the same. They really want to have all these disparate, microsites out there. They want to reduce their deployment costs. And what we've learned from COVID is everyone now wants remote monitoring and control. They can't be on site. They want to be able to dispatch the right people after they understand what the problem is. So it's discovery of what the issue is so they can dispatch the right people to fix it. So with the connected infrastructure, the concept is that I can do remote monitoring control. I've got also the connected machines. So I got machine builders, I got manufacturing, I got distributed power plants. What they're interested in is, improving uptime, doing predictive maintenance, doing, condition-based monitoring. And this is all part of the digital transformation journey. So I talk about convergence of all these disparate devices into one IoT platform. I got all these different sensors out there. I've got, all your favorite automation systems. what we're trying to do is we're trying to take all these different sensors and equipment and have standardized data models such that the automation systems that are consuming that data can operate on it and have seamless interoperability in a multi-vendor platform. There's a lot of different open platforms and open protocols out there. I mean, there's MQTT, there's OPC, there's BACnet, there's SNMP. And once we do this, then you've got the ability to essentially push that data into the cloud and push that thing and allow different levels of applications to merge together. So that's the kind of key thing in the equation right there. I have to talk about one of the organizations I'm responsible for, the CC-Link Partner Association. This is one of the organizations that's pushing the CC-Link IE TSN technology out there, which is part of the critical infrastructure necessary with TSN to be able to do that. With that in mind, you know, there's a lot of things that are going on. We're helping out with the Smart Factory. We're promoting our vendor products, basically, pushing the IE TSN technology. CC-Link, as well as the other industrial Ethernets, it's all about tying all the things together from the device to the controller to the computer, going up in that horizontal period. So if you think about what I talked about, SLMP stands for the Seamless Message Protocol. This is a standardized technology for pushing data. And it's pushing data instead of polling data, which is the key with the TSN technology and what we're trying to do. With that, I'd like to end and close, and I apologize for my picture there, but I'm standing in front of one of my favorite vehicles. And thank you today, really, for attending my presentation and learning more about the industrial Ethernet and the importance of innovation and how you can manage your digital transformation journey, leveraging these technical innovations and specifically the TSN technology.
Well, thanks, Tom. Don't run away yet. We've got questions for you. First, let me mention to our audience that there's well over 100 of you out there. So send your questions to Tom now because I think your questions are typically better than mine. And we want to hear what questions you have. So send us your questions and we'll ask them on your behalf. In the meantime, Tom, we do have a couple of questions from listeners. And the first one is, does TSN require special Ethernet switchers/routers?
No, one of the beauties of TSN, it's a great question, TSN time-sensitive networking, it runs on commercial off-the-shelf Ethernet. There's the beauty of that. So it does not require special switches, special hardware, special cabling. It's commercial off-the-shelf Ethernet, and that's a big advantage for the customers at this point in time. I mean, obviously, you're going to run some switches and you're going to have this capability to bridge different networks. So, for example, if I've got, you know, an existing legacy installation, I'm going to be able to bridge that and put that on commercial off-the-shelf Ethernet with TSN.
Another question. Tom, you've made some great points on interoperability of devices. Do you have any thoughts on the need for a time synchronization for devices so all the data is appropriately organized, maybe NTP or PTP?
Oh, time synchronization is very important. If you think about what you're doing, and I've got multiple machines now communicating together, the time has to be synchronized between the machines. In a world where I'm basically now sharing data between two different machines and I'm historically saving that data, it's so crucial that, you know, the data and the devices are synchronized on time. So the reporting from the two different machines is consistent. That's an absolute requirement. And that's one of the things that TSN does. It provides a way for, you know, essentially time synchronization across multiple devices on different networks.
Good. Well, that certainly seems to be an issue. If I understand it correctly, before I ask the next question, what we're talking about is when you've got events, what is the actual parameter changes that are associated with that event, and getting them in the same time period basically is part of it. Is it not, at least, Tom?
Oh, Kevin, that's a great question, because with events and things like that, you know, you want all these things logged. You want to be able to look at the history of the information and all the different events that have happened. And without having a synchronized clock between all these different things, you wouldn't know where to look. I mean, that's been a problem that's existed for a long period of time. I get an alarm in, and if I get the alarm in and then someone else already fixes the problem associated with the alarm, and imagine if the clocks are not synchronized, right? It could look like I fix the issue, and then the alarm comes in after. With what we're trying to do now is that won't happen because of, in the event log associated with all these different things, all of the clocks are synchronized, and it's synchronized on a consistent basis.
But isn't that what the data historian does historically, is basically normalize that data and contextualize it so that the real relationships between the data are revealed?
That's exactly right. So the data historian basically, it gathers up all the data, but it relies on, the timing, because where it's getting the data from the data sources, it relies on the clocks being accurate with the data that's coming up for the logging applications. But, the data historians typically they normalize all this data and allows you to, make essentially, informational decisions on a lot of the data, based on what's going on your particular factory.
So that was true for the process side of things. Now, when you add IIoT devices, that adds additional data streams that need to be synchronized, which leads, I believe, to our next question, which is simply, please chat some more about timestamps and synchronization of IIoT devices. Is there anything you haven't said on that topic at this point?
There's probably, I could write a book on this topic, because the importance of the coordination and the communication between all these different devices. When you first put a device on the network, the first thing it does is it basically guarantees and has to synchronize its clock with all the other devices on the network. And that's a very important attribute of this thing. And TSN provides a very unique way of doing that time synchronization, and basically, allowing you to continually push, information between your devices, more than just the information about the device and the data I have. You're actually having synchronized clocks on a regular basis, and that's the TSN technology.
So then the TSN technology is overlaid on multiple other standards, so that when it comes to talking about time synchronization, they're speaking the same language. Is that fair to say?
That's exactly correct. So the time synchronization basically runs on the TSN, and then the different industrial Ethernet networks add value on top of the TSN technology. So we leverage TSN, we leverage commercial off-the-shelf Ethernet, and then CC-Link and Profinet, EtherCAT, and Ethernet IP build on top of that and add additional functionality that understands the syntax and semantics of the devices. TSN purely, it doesn't understand the device. It knows how to synchronize. It knows how to let, these synchronize all the clocks. It knows how to provide the ability for, different communication, both control and, configuration on the same wire. You still need the different industrial Ethernet protocols on top of that, which understands really what the device is and shipping the syntax and semantics of the data between devices, if that makes sense.
I think it does. Thank you so much. So do you end up with a situation similar to the old field bus wars, where there's groups of companies gathered around de facto standards, and it takes a long time for them to resolve themselves in the end?
With TSN, I first thought that and I said, well, so how am I going to make all these guys coexist on the same TSN network? The key is there are no field bus wars now. I don't care if it's Profinet. I don't care if it's EtherCAT, Ethernet IP, CC-Link. What I just told you is that it runs on the same physical wire. And basically, the TSN guarantees, delivery, and guarantees the ability for different protocols to run on the same physical wire. So there's a big advantage to this. And the big advantage is it's a single wire, and there is no field bus war. I can take a Profinet device and an Ethernet device, and they can coexist on the same physical wire.
Good. So let's step back a little bit and talk about, you were very much involved in the promulgation of what's turned out to be a really important standard, OPC and OPC-UA. I'm just curious as to what you felt you learned from that experience, and where do you see the standard in its latest, I think, 3.0 iteration?
You know, when I started OPC, I was working for Rockwell at the time, and there were 4 companies, and we all agreed to work together because we're looking at how did we solve the problem of, you know, taking data from this set of devices out here and be able to gather that data in a standard way to the first tier visualization application. Over years, we continued to enhance and blossom. You know, we solved problems of alarming, history, and then eventually back in 2004, we created OPC-UA because I needed a way of doing total platform independence. What I learned from OPC and OPC-UA over, you know, and I guess they consider me the grandfather of OPC because I started it back in 1995, a long time. What I learned was that it's so important to listen. It's so important to, you know, collaborate and work with the competitors and make the competitors check their guns at the door. And literally, we all had to work together, and we had a goal of achieving interoperability with multi-vendors. We all recognized the value of this from an end user perspective. You know, I got a Rockwell device today, and if I want to swap it out with Siemens, you should be able to do that. And that's what the end users wanted. But more importantly, they wanted Rockwell and Siemens and Ether, you know, all their Ethernet devices to be able to talk together. So what I learned is it's not only the communications and the API, it's really about the data and it's about the information. So with OPC-UA, we developed an information model that allowed us to collaborate with all these different standard organizations. And there's over 70 of them now that we've collaborated with, developing, you know, essentially using OPC-UA as a mechanism to consume and understand different data. So whether it's a client server architecture or it's a publish subscribe, I learned a lot. What I really learned is the importance of collaboration, and I've probably overused that word so much, but it's collaboration between end users and suppliers really is the key to developing a successful international standard.
Good, thank you so much. Let's talk a little bit about Ethernet now. I mean, Ethernet has been around for an awful long time. It doesn't seem to be being replaced by anything. What is it that Ethernet does that it does so well that it continues to do it?
You know, actually, when I first started, you know, working in the industry, we weren't even allowed to say Ethernet in the factory floor. I couldn't go to an automotive supplier. You couldn't say Ethernet. So we had to say something else, right? Because they were scared to death of Ethernet because they said, well, Ethernet won't work. It won't, it's not reliable. Well, the reality is it is. I mean, Ethernet is a very reliable network, but so is 4 to 20 milliamp. Okay, so is Foundation Field Bus, all those different networks, and there's a place for everything. But with Ethernet, the capability really is that, I can have connectivity in a very easy way. It's been a standard that has existed for multiple years, and we've all recognized, whether it's wireless or wired, the importance of the Ethernet standards, not only for commercial applications and, for consumer applications, for the industrial automation world. There's no factory that doesn't have Ethernet in their factory anymore. They all recognize we have to. This is our connectivity.
Good. Another question from a listener. Can TSN traffic be throttled or prioritized when the bandwidth starts to constrict? What are the failure mechanisms that an engineer needs to consider when using TSN?
So there's a lot of tools and things that are going to be out there that are already there for the TSN technology. With those tools, basically, you'll be able to take a look at, making sure that you're not overutilizing the network. But also with a lot of the applications and things and the devices that we're working with, you know, Kevin, there's a whole difference. I mean, I talk about exception-based processing. So yes, you've got terabytes of data, but if you start thinking about pushing the data that changes, you actually reduce the amount of data that goes on the same physical wire. So this isn't a polled scenario anymore with the TSN technology. You're actually pushing data. And this is the beauty of IoT devices. They're really only pushing the data that changes. So you're not streaming the entire, you know, architecture of, you know, my data from my device. So, but there could be issues and things, and with the tools, basically, you'll be able to take a look at this, and if necessary, you can configure your TSN network to prioritize, you know, which protocols get priority.
Good.
But I don't see that being needed in a lot of ways, to be honest with you.
Good. At the end of the day, with field bus networks and other types of networks, getting up into the enterprise networks and supply chain networks, how many different networks should an industrial plant typically have today?
You know, I'd like there to be one, okay? But the reality is, because of all the different legacy networks that are out there, you know, I got the opportunity to go to many different customers over my career. And in the last year, I've been visiting a lot of different customers as we come out of the pandemic. And, you know, they all have different devices. They all have different reasons. They all have different networks. So, you know, it's a matter of, with TSN, we're going to be able to have connectivity with bridges and gateways from all these, you know, existing legacy things that they have out there. So, you know, we've got to support those, right? Because in a lot of applications, particularly in process, once they've gotten something approved, or from a regulatory standpoint, they can't swap it out. If it's not broken, they can't fix it, but they still want connectivity. So the simple answer to the question is, you know, it's going to be whatever the customer has. We should be able to make work, you know, both the old with the new.
Good. All right, we've got a couple of minutes left. A lot of people still listening in. Send us your final question, and we'll wrap it up here pretty quickly. Tom, you haven't talked too much about the cloud. You mentioned the cloud, but it doesn't seem that the networks that you're most concerned with are extending up into the cloud. Is that a misimpression on my fault, or is there a differentiation between your area and cloud?
You know, there's a lot of activities that are associated with, you can run applications in the cloud. Most of the people look at, and, you know, it's just a right thing to go do, because it allows you, you know, the capability of, you know, switching out and updating an application without having it, you know, localized on your own PC, right? But more importantly, what we're seeing is we're seeing a lot of push of the data, the information into the cloud, whether it's on-premise or off-premise, and then you're running applications in those cloud that basically takes a look at that data and allows you to make intelligent decisions. So in the IT world, for example, if I can make the data available to these guys, then they can do things magically with that data, you know, to really help improve the operational efficiency of their respective, you know, industrial automation applications.
Good. All right, final question, Tom. What I ask a lot of times when I interview, is there anything I should have asked you that I haven't asked you?
I guess no, but I'll close with one thing. The most important thing is that industry standards and all the work going on with technical innovations, there's a lot of technical innovations that happen that go by the wayside. But you have to be willing to adapt and remember, you know, a lot of these innovations, you know, success of those innovations depends on the level of adoption of them. OPC, for example, is one of those classic cases that it just took off. You know, there was a reason, it solved a problem that end users wanted solved. I believe the TSN technology also solves a critical problem that end users really want. They want all their protocols to run on the same physical wire, and they don't want to lose data. And that's the key thing, right? You don't want to lose data anymore. So that's kind of the key thing. It's all about reliability, Kevin.
All right. Well, we really appreciate you stopping by, Tom. Want to thank our audience for sticking with us and for the great questions, just as I know you all want to thank Tom for sharing his time and expertise. Before we go, I'd also like to thank Epicor and GE Digital for sponsoring today's event. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Take a moment to complete it, because we use this information to improve our webcasts. Finally, on behalf of CFE Media and Technology, I'd like to thank you all for attending. This concludes our webcast. Thanks, and we'll see you next time.